a function is increasing, okay, whenever it's going up from left to right, right? So as we go from left to right, we see an increase, there's an increase, and there's an increase. So 3 separate intervals where it's increasing. And it's also decreasing for 1, 2, 3 intervals as well. Okay? So for letter C, for example, the given function is increasing or decreasing on the interval from 2 to 4. So again, looking at your graph there, is the function increasing or decreasing for x values between 2 and 4? Decreasing, that's right, it's going down from left to right. Decreasing. How about from 4 to 6? From 4 to 6, what's happening? Increasing or decreasing? Increasing, yeah, very good, guys, very good, okay? Now, one other big topic, and I don't know why this is stressed so much, but the idea, this other topic, this other characteristic is called the average rate of change. So this one's so important, I'm going to underline it here because this one, I know you've seen increasing and decreasing before. I don't know if you've seen average rate of change before. And again, it gives a kind of a weird definition here. It says it's the ratio of the change in the function values, f of x2 minus f of x1, to the change in the x values, x2 minus x1. Okay, so basically it's the slope between 2 points on the function. Okay, that's like, I'm going to give you like a better definition, I think. It's just the slope between 2 points on the function. So in other words, all you have to do to find the average rate of change, it's just the slope formula. y2 minus y1 over x2 minus x1. That's all it is, okay? That's what you need to do to find the average rate of change. Okay? Should you ever go to calculus and take calculus, you'll actually use that formula in calculus 2 along with finding the instantaneous rate of change. That is the rate of change or the slope at a single point, okay, which involves using limits and other things and stuff like that too. Okay? For a linear function here, it says the rate of change is constant and represents the slope of the function's graph. So that's pretty obvious there. So letter E here asks, what is the given function? So again, going back up to our graph here, what is the given function's average rate of change on the interval from 0 to 2? From 0 to 2. So to do this, we have to figure out what the points are. So at 0, we're at the point -1. So we have the point 0, -1. And then at 2, we have the point 2, 1. Right? The x value of 2 gives us a y value of 1 according to our graph. So 0, -1, 2, 1. We want to find the average rate of change, which means we just want to find the slope. That's it. Find the slope between those 2 points. From the x value 0, which is the point 0, -1, to the x value 2, which is the point 2, 1. So we'll just do the slope formula. That's it. 1 minus -1, right? y2 minus y1 over x2, the 2, minus the x1, 0 there. That's all there is to it. So instead of minus and negative, make it plus positive. We have 2 over 2 minus 0 is 2. And so 2 over 2 is just 1 over 1, or you can just say 1 if you want to, either way. Okay, so that's the average rate of change. 1 over 1 or just 1. Okay. Okay. Questions on any of that so far? All right. So then some other stuff here. A function may change from increasing to decreasing or from decreasing to increasing at something called turning points. All right. The value of f of x at a point where a function changes from increasing to decreasing is a maximum value, right? That makes sense. If you change from increasing, you're going up, 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 to decreasing, down, 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 you have to hit a maximum point, right? Increasing to decreasing, you're hitting a maximum point. Likewise, if you change from decreasing to increasing, what kind of point is that you hit? Decreasing to decreasing, the minimum, right? Because you've got bottom out and you have to start increasing it. So it's a minimum. And that's what you see right here. Okay. So, letter F here asks, at how many points does the given function change from increasing to decreasing? So looking at our graph here, how many points does the function change from, at how many points does the function change from increasing to decreasing here? What do we say? Looking at your graph there for number 17, let's go to, oh, someone who's here. Let's go to Andrew. What do you say there? How many times does our graph here change from increasing to decreasing? For the whole picture there, yeah. Well, let's see here. So, it's not 6. Nope. No. Again, I think you're counting like increasing to decreasing or decreasing to increasing. We're only counting for when it changes from increasing to decreasing. So right now, what's the behavior right here? Are we increasing or decreasing? It's 3, exactly right. Increasing to decreasing, that's 1. Another increasing to decreasing, there's 2. And then increasing to decreasing, that's 3. Okay? So since we have 3 of those points, that means we have 3 different maximums, okay? 3 different kind of like maximum values. Well, not 3 different maximum values, but 3 locations there. Okay? So the next question, G, asks, what is the function's value at those points? And so, Andrew, what's the function's value at those 3 points where it changes from increasing to decreasing? It's at a value of 1, a y value of 1. So, yep, let's make that 1 there. Okay, so 1. Okay. Now let's see here. Let's go to Carlos. How many points does the given function change from decreasing to increasing? Yes. Go back to the picture here. So exactly right? We might be tempted to say it there, but it's only changed from decreasing to increasing once, twice. Okay, because there's no decreasing behavior before this. So yeah. So it's just 2. And what's the value at those points, Carlos? Yeah. Yeah, like at the actual point where it turns, what's the y value, or what's the function's value, or the y value there? Right, and so the value at this point, where it changes from decreasing to increasing, what is the function value right here? So yeah, and just the function value is the y value. So all you have to just say -1 then. That's fine. Yep. You knew what you were saying. I mean, you gave me plenty of information there. So yep, what is the function value? It's just -1. Okay. All right. Last thing, and again, you guys have seen this before, so I want to kind of just get through it. Okay. A 0 of a function is a value of x for which f of x, the function's value, is 0. Okay. On a graph of the function, the zeros are the x-intercepts. So when you hear the word zeros, same thing as x-intercepts, right? Same idea. So, going back here one more time to the picture, flipping back and forth, right? Let's go to Katie. Katie, let me see. I think we were supposed to ask how many. Yes. How many x-intercepts does this graph have? How many times does it intersect or touch the x-axis, in other words? Yeah, so we are going to count this one because it is touching the x-axis, so it counts as a 0. So yeah, 1, 2, 3, 4, 5, 6. And then, Katie, can you identify the zeros? That is, what are their x-coordinates? We know the y-coordinates have to be 0. So what are just the x-coordinates there? 1. Yeah, it's all the odds in this case. Kind of interesting. Okay, that's right. 1, 3, 5, 7, 9, 11. Okay. So there it is. 1, 3, 5, 7, 9, and 11. Okay. And that's all we're going to focus on here. We're not going to look into like sketching a functions graph from a verbal description or any of this stuff, so we'll just skip ahead. But I do want you to skip to page 24, and I actually want you to try numbers 1, 2, and 3 here, just to make sure we're okay with this stuff. So try 1, 2, and 3, please, just as an opportunity for you guys to see what you can do there. Okay, answer those 3 questions for me, please. So for number 1, by the way, right, when it's asking on what interval, you're going to use your x values to describe that. So again, for the increasing piece, or for the decreasing piece, you want to see, okay, where does it start to decrease? At what x value does it start to decrease? And at what x value does it start to stop decreasing? So go ahead and try and describe that for me, okay? Try to find you, Connor, on page 24. Next question. No, it's okay. And I'll let you decide what kind of notation you want to use. If you like inequalities, use inequalities. If you like intervals, use intervals. Okay? I'm probably going to use intervals. It does say number one, it says on what interval, but I think you could also use an inequality to describe this if you wanted to as well. But I'll be using intervals. Perfect. It starts at 3. Where does it stop? Yep. So you want to say comma 13. So you want to know where it starts decreasing and where it stops decreasing for the entire interval there. Does that make sense? And then I would put parentheses around those. If you do put those, okay, on what intervals does the function increase? So now you look at the graph where it starts. 13 again, no, 13 again. Where's the stop? Yep. There may be more than one interval, folks, where it's increasing or where it's decreasing, so please keep your eyes open for that. If you're unsure, you want to ask questions, please let me know. Right, I know. So what is it then, right? So if we look here, all right, it goes 1, 2, 3, 4 boxes. So what would that have to be then? Yes, very good. Good for fractions, yes. Okay. 30 more seconds here, and then we'll get some questions. Go over it, I should say. Okay, so Eve, what were you able to come up with here for the interval where the function is decreasing?
Said that it starts to decrease at
3, okay.
and then it's 2.5.
And then you said it decreases to...
Oh, I don't really know like how to do it, so I just have like the point.
Like you gave me the y coordinate. Like you said, the point it starts to decrease at the point 3, 2.5 is what you're saying. Okay. All we need to worry about here when we're describing the interval is the x value where it starts and the x value where it stops. So you can ignore the y coordinates. Just so what's the x coordinate of where it stops decreasing? 13. Okay, now did you want to use interval notation, or did you want to use inequalities? What did you want to use? Interval. Okay, so it'll be 3 and then comma 13. And then as far as the grouping symbols go, I'll be kind of flexible with this. I think technically it should be this. We don't want to include the starting point and stopping point, okay? Because at those points, it's not really increasing or decreasing. It's kind of flat, right? It's kind of flat right there at 3. It's kind of flat right there at 13. But 3 comma 13 would be it, okay? So just 3 to 13. Just the x-coordinates is all you have to worry about with that. Okay? But otherwise, very good there. Thank you, Eve. All right, let's go to somebody else. Let's go to Carlos. Your number's up again. All right, so identify, on what intervals is the function increasing, Carlos? Yes, please.
So also the interval, so
Say again?
wait, this is the x, right? So we also have 13.
13
All the way
to 18, perfect. And again, I'm not going to include the 18 because at that 18, it's kind of like with the end point, so okay. Anywhere else? Is it increasing anywhere else?
Also from 0 to
3, yes. Okay. Now, when we have two separate intervals like this, and we want to say that both are true, we're going to put a little u in between. Yeah, it's a union. Exactly right. It's exactly right. It's a union. Okay, we union. We put those together. Okay, they're joined together. A union. Okay. All right. Very good. All right. Let's take a look here. Number 2. Then identify any maximum values and any minimum values. Okay. Let's go to Estefania. What do you say there for number 2? What's the maximum value or the highest value? Yep, so again, in this case, if you want, you can just say the maximum value. You can say the maximum value is 3, or you can give the point if you want to 18 comma 3. That's fine too. But understand that 3 is the value. It's the value of the function, right? It's that y value there. Okay. What about the minimum value? What would that be? Yeah, very good. Okay, minimum value is 0.75. Those tick marks are counting by quarters. And we know that because it takes 1, 2, 3, 4 blocks to get to 1. So that means each block is 1/4. Right? If it takes 4 blocks to get to 1, those are each 1/4. So 0.25, 0.5, 0.75, 1, 1.25, 1.5, 1.75, etc., etc. So very good. Okay. And last but not least here, what is the function's domain? Let's go to Connor. Can you help us out here, please? What's the function's domain for this picture here?
0, 18.
Okay, 0, 18. Wonderful. And do we include or exclude?
Include.
Yeah, include both, actually. You're right. Okay, that's the domain. What about the range?
0.75, 3.
Okay, and do we include the 0.75?
Yes.
Yes, we do. We do basically hit it there. And then up to the 3, do we include the 3? Yes, we do. Good job. Okay, wonderful. That's it. Okay, domain and range. All right. Okay, cool. I want to turn to one more thing here, and that is we're going to talk about transformation. So if you would turn to please page 31. Okay, turn to page 31 here, and we're going to look at transformations. This will be the last thing, and I'll let you guys get started on your assignment. So, this shouldn't take more than like 5 or 10 minutes, hopefully, and then you guys have a good amount of time to still do your assignment. Okay. So, and we're not going to finish transformations today. We're just going to kind of get started with the transformations here. Okay. So, actually, what I'm going to have you guys do, this is explore or an investigation. So, I'm actually going to have you guys try this one on your own. Okay. So, I'll just read the introduction here, and then we'll kind of get you started on this. So, it says here, you can transform the graph of a function in various ways. All right, you can translate the graph horizontally or vertically, and right, the word translate really just means to do what to the graph? You move it, like slide it, right? The orientation stays the same, but slide left, right, up, or down. And you can stretch or compress the graph horizontally or vertically. That's also sometimes called a dilation, right? and you can reflect the graph across the x-axis or the y-axis. Okay, today we're going to focus just on the translations for right now, and then tomorrow we'll look at the other stuff if we have time after the quiz and stuff. We'll see. Okay, how the graph of a given function is transformed is determined by the way certain numbers called parameters are introduced in the function. Okay, so say that we've got a graph of f of x and it's shown right here. Okay, so there's our graph of f of x. And we're going to use this graph to help us kind of complete our tables here. Okay, so the first question here is the first thing is to graph g of x equal to f of x plus k. So you notice the plus k is on the outside of the function f, where k is the parameter, right? So we introduce this new number k, and we're going to add it onto the outside of the function f. We're going to let k equal 4, so that now g of x is just going to be the function f, this function f here, plus 4. We're going to complete this input-output table and then graph g of x. Okay? And then in general, we want to answer the question, how is the graph of g of x equal to f of x plus k related to the original graph of f of x, when that k is a positive number? So in other words, you'll see here they already regraphed f for us. We're now going to fill in the rest of this table and then graph the -1, 2, the 1, 6, the 3, blank, whatever that is, and the 5, blank, and see how that shifts things. Okay? So we'll do this one maybe together here. I think I've got space for it. Nope, okay, I don't. So we'll just do it on this one too. But let's just do this A together. So you can see here we've got some inputs. Okay, -1 for an x value, 1 for an x value, 3 and 5. And then when you plug those into the function, you can see here that -1 gave us a -2 function value. 1 gives us a +2. 3 gives us -2. And then 5 gives us a +2. But we're going to take those function values now, we're going to add 4 to them, right? Because we took our function, we're adding 4. So -2 plus 4 gives us 2. 2 plus 4 gives us 6. Then -2 plus 4, well, that's going to now give us 6. And then the 2, but adding 4 to it is going to give us, oops, I can't add. -2 plus 4 is 2, and then 2 plus 4 gives us 6. Okay, and so now we're going to plot these new points. Still have the x value of -1, but it's going to go up to 2 now. Okay, still have the x value of 1, it's going to go up to 6. Okay, and we'll connect those dots. 3 now goes to 2, and we'll connect the dots. Ooh. And then 5 goes to 6. 5, 2, 4, 6. Okay, so there's our new graph. So, in general, how is this graph right here related to the original graph there in black? What happened? Yeah, that's definitely. Yeah, it split up. And can you be more precise? How much did it split up? 4, exactly right. Okay. So in general, Estefani, to answer this question, in general, how is the graph g of x equal to f of x plus k related to the graph of f of x when k is a positive number? So what can we say? This g of x will be shifted up how much? Well, now we're talking about, so if k is 4, it'll be shifted 4 up. But what if it's just a generic plus k? It'll be shifted up how many units? K units, exactly right. If k is positive, it'll be shifted up k units. And that's the idea. Okay? So, if k is positive, g of x equal to f of x plus k is k units up from f of x, the original f of x. Okay, so if you take your function and you add a number onto the end of it, that's going to shift it up, shift the positive number up. Okay? So now you guys go ahead and try it with a negative number, okay? So you guys try here letter B. Now try a negative value of k in g of x equals f of x plus k. So you're going to make k -3. And so go ahead and just fill in the rest of this table and then graph it right here on that same graph to see what happens. Okay? I'm going to get a different colored pen here to hopefully make it stand out. So let's see, I think I have a purple pen. Okay, so go ahead and just fill in that table. Or you may not even need to fill in the table. You might already know what you're supposed to do. You're going to do that. Okay. negative 5, 1, negative 1. Beautiful. Now, you can also put on that kind of thing. It's up to you, but if you don't want to do it there, that's fine. I'm not going to. If you want to try and answer the question, perfect, good job. I'm sure about how to fill this out. Oh, okay, gotcha. Okay, looking good, everybody, looking good. And not only did it go down because it was negative, but it went down exactly that amount, k, right? So that's the idea, though. Yep. So there's the graph. Okay, you should have a negative 5 and a negative 1 filled in there, again, because the 3 gave us a function value of negative 2, so 3 plugged into the function gives us negative 2, but then if we take that function value and subtract 3, it's now negative 5. So the point now is 3, negative 5, and the point here is 5, negative 1, and 1, negative 1, and negative 1, negative 5. You plot those points, and there it is. That's supposed to be purple. I don't know if you can see it very well, but there it is. Okay? So I saw a bunch of people that had already answered this question, so does someone want to volunteer what they wrote here for this question? Someone want to volunteer? What do you write? What did you write for letter B there? What did you write for letter B? Yeah, Josh, go for it.
If A is negative, gx equals fx plus a is k units below fx.
Okay. Wow. Yes, I didn't want to talk because I didn't want to lose what you said. That's perfect. If k is negative, g of x equal to f of x, and I'm going to actually I'm going to leave it plus k. Because here's the thing, if I put a minus k there, and if I said k is negative, a minus a negative number would actually then be positive and actually be shifted up. So I want to be careful. It should be, if k is negative, g of x equal to f of x plus k, again, k would be negative, so you'd be adding a negative number, it would actually then go k units below f of x there. But that's exactly right, it does shift down that amount. Okay, wonderful, good job there, exactly right. Okay, now, go on to the next page here, and we're going to look at one more thing, okay, just to kind of see how this works. And this is our last little table, and we'll do this one together. Okay. Now, okay, we're going to graph g of x equals to f of x minus h. Notice now our parameter, okay, we've changed it from k to h. We're talking about h now. H is the parameter, and you'll notice it's inside with the x. Okay, so we're going to let h equal 2, so now it's going to be g of x equals f of x minus 2. And we're going to complete this little diagram right here, okay, and then graph g of x. Okay, so we're going to have to work backwards here in order to do this. All right, so if you look here, goodness, okay, so when we plug in, for example, 1 in for g of x here, it's going to be 1. Oh, I better write this out so we can have it. Sorry. Remember, our function here is g of x equal to f of x minus 2. All right, remember that, minus 2. Right there it is, right there, 2. I'm going to write it down here, too. Okay, so we're going to plug 1 into g here. And so we have to plug the 1 in for the x. 1 minus 2, that's the input for f. Then we're going to plug negative 1 in for f. Okay. And then the negative 1, the output is negative 2. And so then g will also be negative 2. Okay. Here for 3, we're going to input 3 for the x. Minus 2 gives us a 1. Okay. And then f of 1, well, if you look here, f of 1 is 2, so we get an output of 2. And then that's going to equal to g of 2. Okay. And then what is input for g to then result in a 3 here? So what number do we have to plug in so that when we subtract 2, we get a 3? What number is that going to be, Carlos? 5. Yeah, 5. Exactly right. Okay. 5, subtract the 2 gives us the 3, and then f of 3 is negative 1, or sorry, negative 2, and then the output will be also negative 2 for g. And then finally here, what about for this one? What does this input have to be if we then result in plugging in 5 for f? So what minus 2? 7. Yeah, 7. Okay. And so we have these points then. We have the point 1, negative 2. Right? We start with 1, we end up with negative 2. We have the point 3, 2. We have the point 5, negative 2. We have the point 7, 2. Okay. 4 of them. And we'll plot those points. 1, negative 2. 3, 2. 3, 2. And we'll connect them. 5, negative 2. Connect them. And then 7, 2. 7 is all the way at the end there and up 2. Okay. So, how does the original function, well, if we take the original function f of x, how does that f of the quantity x minus 2, how does that relate? What happened here? What happened to our graph? Moved over to, in fact, over which direction? To the right. Exactly right. Okay. So, g of x equal to f of x minus h, okay, is h units to the right of f of x if h is positive. Okay, which is kind of backwards, right? When we see an x minus 2, it would make more sense intuitively for it to move which direction? When you see a minus 2, does that make you think to the right or to the left? To the left, okay? But in this case, it's backwards. X minus 2 actually shifts things to the right 2. X plus 2 shifts things to the left 2, okay? So if h were a negative number, which means it would be x plus h, then it would be shifted to the right. So that's backwards from how we shift things up and down. If you want to shift something up, you add a positive k to the function at the end. If you want to shift something down, you add a negative k or subtract k to make it shift down. But if you want to move something left or right, okay, if you want to move something left or right, you're going to subtract a positive h to make it move to the right. You're going to subtract a negative h to make it move to the left. So positive h to the right, negative h to the left. Okay? So, that's the idea there. All right? Questions on any of that? Okay. So what I'm going to have you guys do then is this. So we're going to go back for your assignment, for your homework. Okay, here's what I would like for you to do. So back on page 12, okay, I'd like you to try numbers 2, 4, 5, and 6. 2, 4, 5, and 6. Well, you're going to get started on it in here. If you don't finish it, it'll then become homework. Okay, if you don't finish it. So 2, 4, 5, and 6 on page 12. I'll write that on the board here too, because I want to assign something from the other sections. 2, 4, 5, and 6. Okay, and then on, ooh, goodness. I don't want to do too much there. We'll do page 25. I'd like to do numbers 7, A, and B. Just the A and B part there, and then also numbers 8, 9, and 10. Okay. And then page 41, numbers 1 through 4. Okay, and those should be super quick, Okay, you have a good, 15 minutes here to get started on that. So, I mean, you should knock out a good chunk of that, if not the whole thing, if you work diligently, I'll say. And I'll come around and help you guys as you need, okay?